Hi, Jeffrey. I thought I would explain what's going on a little bit more. Yeah, you have a good question. And this part of the class is really the most complicated. So I think at the very beginning, I just understand the concept. And then actually, if you're really interested, really go through and maybe in a later class, you can look at the chemical reactions because that's actually really fascinating. I know I think I probably mentioned that I always had respiration in almost every one of my biology classes, and I really hated it. But when I took biochemistry, I really understood, what was going on at the chemical reaction level. But I think at the very first step, just if you can understand what's going on, I think that's really the basic thing. And then maybe in your next class or even a little bit later, go back and look at it a little bit deeper. So it's one of those things that you need to understand in layers. Okay, so this is the Krebs cycle. It's also called the citric acid cycle or the TCA cycle. I don't know why they have so many names. I think your Khan Academy talked about 4 carbons. Don't worry about that. That is just how this what this byproduct is. So this is a cycle, and it just cycles through and does different chemical reactions. And basically, we're just going to get a few NADHs. That's going to go off into the electron transport system, and we're going to make a lot of ATP. So that's the goal, a little bit of ATP. And then we'll get a lot more ATP in the electron transport system. So we're just going to make NAD, FAD, and some ATP. Okay, and so all we're going to be doing is taking carbons and then extracting the energy from the carbons and then turning that into energy for ATP. And all oxalic acid is, it itself has 4 carbons, and that's what Khan Academy is saying. But you really don't need to know that. That's just the what this is. So just the resultant. So this always cycles through. So we're gonna begin and end at the same point. So we're not gonna lose anything. So oxalic acid is 4 carbons. That's just the way the chemical is. So your body makes that oxalic acid. And then we're gonna be adding the 2 carbons from the glucose. So it comes in as acetyl-CoA, and then that starts the citric acid cycle. So then we're going to add the 2 carbons, and then we make 6 carbons. Okay, and we're going to cycle through this, ending back at 4. And then we lose the carbon. So we're going to add some water, and we're going to lose the carbons and carbon dioxide. Oh, yeah, just to show you. It's not really well labeled here. So this is carbon dioxide, and this is carbon dioxide. So we're going to have 4 carbon molecule. Don't worry about that. We're going to add 2 carbons to it through acetyl-CoA, and again we got the 2 carbons from glucose. Glucose has 6 carbons. Glycolysis, or lysis means cutting of glucose. We're cutting it into glucose is a 6 carbon molecule. We're cutting that into 2 3 carbon molecules, and we're going to lose CO2. So one of the carbons is going to be released as carbon dioxide, and then the other 2 is attached to acetyl-CoA. Okay, so acetyl-CoA comes in, and then the 2 carbons becomes added to oxalic acid, and then we form a 6 carbon citrate. And then we're just going to go through, and then there are different enzymes that just make these little tiny changes. And so we go from citrate to isocitrate to alpha ketoglutarate to succinyl-CoA to succinate, fumarate, malate, and back to oxalic acid. So there are different enzymes here that do different reactions. And this one will produce NADH. And then we're losing the CO2 here. We're losing CO2 over here. So it's kind of like a cycle. So each one of these, so there's an enzyme that does this, an enzyme that releases water, and then brings it in here, and then another enzyme here. And so these are just the intermediate, these are just the byproducts of the different enzymes. Okay, but for this very first class, don't really worry too much. Just get the overall understanding, and then you can dig deeper and deeper as you go into different chemistries and different deeper biology. So it's good. It's really important to get the overall concept in this class, and then you'll delve deeper. But yeah, I hope you take biochemistry because it is really fascinating. You'll look at the different enzymes and how they capture some of these molecules and turn it in a certain way so that you can have these chemical reactions. Okay, so again, the 4 carbons come from, it's just the byproduct, oxalic acid. So from the enzyme that releases this. Okay, so again, we start with 2, we add the 2 to the 4, which makes 6, and then we're just going to go through this cycle, and we're making NADH, a couple of carbon dioxides, and then extracting energy and NADH, which will go on to we'll use the ATP for energy of the cell. We'll use the NADH and FADH2 into the electron transport system. Okay, yeah, I love your questions, and it's great that you want to get into the detailed. So anytime you want to know a little bit more, let me know, and I can explain it deeper, because I don't know, I really liked it. It's really fascinating, so I hope you find it fascinating too. Okay.